Okay, it's about time, and since we're quite tight in schedule, so today we're gonna see some less basic examples. We're gonna see how we can further customize a test. I'm gonna still showcase everything live here. And yeah, that's the plan of the day. There are several examples along the way. And you can also try them and follow me. Let me just check if, okay, this is still defined. Okay, so we've seen in the previous tutorial the test parameterization. In this one, I'm just showing another different way, also another way that you can write and generate like long sequences of um, parameterized tests. So again, I'm getting the stream benchmark, and now it's parameterized in this way. So essentially here we want to parameterize on the array size, and then we have a bigger range. So it's not just that we hard code everything, which we take different powers, and we powers of 2, and then we have the array size. We do some math here, also number of times, and then we set it up here when we compile. So again, you see it's just a single test, and we're going to see that we're going to generate several. I think, no, we don't need anything else here. Is we want just the GNU. Yeah, I'm going to pthread here as far as I remember. Nothing new here. I'm gonna also add those. I think it's 16. It's here too. And another thing is here is another little trick when you don't want to have your reference values, but you want to have units because you just, when this is reported or when this is logged, it's better if you have units rather than not. All you have to do is put here a star, which means that reference is valid for any system, and it's like a fallback. And then list your variables, and you put a reference value of 0 and no bounds, and just put the unit. Yeah, we do that also as a fallback in some cases, or when you don't want to publish your numbers, but you still want to log them with units. So that's it. Let's try this thing, and let's see what it gives us. I'm not gonna run it first. I'm just gonna list it just to show you. Okay, so you see, so we had like 11 versions, and if I want, because this is also a bit, the syntax here, it might be a bit strange, but essentially what we want to produce is such a list, because every parameter, every argument of the parameterized test is a list of arguments to be passed to the constructor here. So here we have a generator that generates those lists, and then we simply unpack that generator. So in case you wonder if this strange syntax, and sometimes can be a bit error prone to get it right. But that's one example. I'm not going to run those, but you can try them. Now there is a nice thing, which this I don't have it in the tutorial, but I can do it right now on the fly. So there is a very nice function that finds, for example, all the different modules and generates tuples of valid systems, valid programming environments, and module combinations. which really allows you to test. So here, I think we have Gromax. So what am I going to do? I'm just going to copy this into, okay, I'm going to create, perhaps it's better if I'm here. It's advanced. Okay, so I'm not gonna create a full test, but I'm just gonna show you this in order to see how it looks like. I forgot to import something. Okay, so to see how this gets parameterized. I don't like this. Okay, tutorials, advanced. Okay, let's see. I hope I haven't messed. Okay, it loaded the test. It takes some time because behind the scenes, it uses module avail. We could have a version that uses Spider for L-mod backends. Okay, the output is a bit crumbled here, but you can see, for example, the different combination. It's gonna load Gromax 2004 version. I think the module is named Gromax 24 FOSS28 Python 382. That's the module name. And then we converted the non-alphanumeric characters to underscores. And you see it generated basically for every system, for every partition, a test. And there is also one thing here that we can pick a test and we can list it in more detail so that we say. So here are I just picked one. So here is the Gromax test using that module and yeah, on the built-in and EUM, and then it can do it also on FOSS. But in that particular case, you can also, I'm gonna go here because there is another parameter that's quite interesting. So here, I think, Victor, you have flat module name scheme, right?
Yes.
And that's why we get all these unnecessary combinations, because normally, if you have a hierarchical name scheme, what I need would just give you the right combinations. Now, if you have a flat name scheme, you can pass a mapping of between the toolchain that is inside the name and the toolchain or the programming environment of ReFrame. Because, for example, here we essentially we don't need all those combinations. So, and this is going to happen like in this example. For example, I'm matching whenever I see Craig GNU, I'm matching it to the PRGN GNU, and I'm going to do exactly this, and I'm going to have some. I'll put it here. So environment. That's useful when you don't have, when you have flat schemes. Okay. And then okay, let's call it FOSS for all the versions of FOSS we can find, and that we just map it to FOSS. To the FOSS internal environment. I think we're done. Let's see now what we are going to get. Oh, I think I forgot something. Oh, yeah. Oh, yeah. Just a second, functors, partial, final. Oh, yeah. Yeah, let's do what I have here. Do this. here, map it to false. Okay, let's see now. Yeah, of course. Sorry. What am I doing wrong? Yes, of course. Okay, yes. Sorry for that. Why doesn't it like it? Must be dict of strict and string and string. Environment mapping thing. Okay, so that means this example is wrong. Okay, we found a bug in the documentation. And I was wondering why I had the okay, so now you see, I mean, we didn't get all the unmeaningful combinations. So we get, you see the 3 versions of GROMACS that they are installed, 20.2, 2, 3. So practically this, we can, with just a simple file, we can parameterize it and test all the modules in the system, which is, yeah, quite interesting. Actually, we don't have a production test with that. I don't know if you, Victor, has written anything that uses it yet.
Yes, I have one test case, yes.
Okay, so moving on, here we're going to show, for example, how ReFrame deals with make files in different build systems. So here we have a dot product example that resides here. And again, there's a small bug here. So you can see, again, as I said before, now the SRC now in the directory, there is a make file and then the code. So let's see the test. Let's go to the first one. So here the change is, there are 2 changes. So you tell ReFrame that it's going to use make to build it. Actually, we wouldn't even need to do that, this thing, if we didn't have to pass any flags to make or any options. But now, since we need to pass the CPP flags in order to select the element type, we just also define it here. Now, since whenever you use make, CMake, or auto tools, ReFrame doesn't know the executable. So here you have to specify also the executable. And other than that, this test does not introduce anything new. But let's run it. Just select the make file test. And actually here, it's not an exact matching, this one. So this is a regular expression. So it's going to select both float and double to run. It's a thing to bear in mind. Okay, we just had GNU, but never mind. So now let's see the output. So the output is, no, ReFrame EUM, we run on, let's get the CN, GNU, double, and the bit, so here is what it generates. So essentially, as we said, the loads, etc. By default, it does make -J1. And then it passes all these variables based on the environment. So if there are cases that some make files, or even if you're using CMake, when you do the make, no, in the CMake it passes those in the configure line, not in the make line. But there are some cases that some codes don't like that. So in that cases, you can tell ReFrame not to pass those flags. And we can even try it right now. And it will just generate only what he passed, nothing from the environment. And of course, then you can even set the concurrency, how many jobs you want, and you can also have custom make files. Okay, so you see that it didn't put any of the variables. So the same you can do with CMake or AutoTool. So you can, there are other build systems that you can here, for example, say CMake, and then there's also specific options. Again, those tools are really not so sophisticated as easy build, or because the purpose is completely different. It's just to be able to compile a test code. And then there is another interesting thing. We haven't seen that yet. So of course you might need to just clone something. You've seen before that we, in the stream test, that we just a question I'm seeing in Slack. Could you make that HMNS aware? Which means, sorry, I can't understand that. So here you see, yeah, please. The
HMNS is hierarchical module naming scheme.
If you have I need to check, Victor. I'm not so much into the modules.
Sorry, I didn't understand the question.
Hard module namings.
What was the question?
I think, Ake, we can unmute. Okay. Yeah, that's certainly, I mean, that's something that can be done on the backend. So transparently to this, yes, because now it's done outside any, it's not module specific. Okay, so here we've seen also the pre-built CMD. So essentially what you could do is say that the sources there is none. That means that don't try to copy any resources and just do the git clone here. But for convenience, there is also, you can put the repo here in the sources there. So, and here we accept URL. So it's not going to accept the SSH syntax, the SCP style syntax, but you should use the SSH protocol. You can see the Git documentation in case you wonder. Now, another thing is sometimes you might have a code that uses its own configure script, not CMake, not AutoTools. So in that case, again, you can do, you might use a build system make, not CMake or anything else, and then just pre-build commands, your custom configure, and so on. And you can see that it generated. Another category of tests is what we call the run-only regression tests. I don't think we've seen one so far. It's basically the test that you don't have to compile anything. So you just have to run something. It could be that you load the module and you just run the executable, or you just run a utility. So they're exactly the same as the standard ones, except that there's no build phase. And the resources of the test, again, tests may have resources, which again reside, let's see the test instead of just talking. So it doesn't have resources. So again, the resources would be under an SRC directory. It's exactly the same as the other tests. And there, whatever is there, it's going to be copied. And yeah, and the copy is going to happen just before the run phase, I think. No, just after the setup. So this one is yeah. So in all the Runonly tests, you have to set the executable, apparently. Nothing special here. Okay, let's run it just to be complete. And then we have the compile only tests. Those are the tests that they actually they skip the run phase. They don't have any run phase, but they do have sanity and performance phase. And in this case, you can use basically the same idea with a test, but and then you can use the sanity patterns to look into the output of the compilation or the standard error. So yeah, then we have this make only test, for example, that essentially is just a compile only, and the sanity patterns, they're only following the okay, yeah, we're just checking there are no warnings. One thing is that I haven't mentioned is that ReFrame doesn't check the exit code. So it will not mark a test as a failure if it exits one, and that's in purpose. It doesn't happen this for the compilation phase. In the compilation, if anything in the build script fails, it will mark the phase as a failure. But for when you are running, then exit codes are not taken into account, because there might be several, you might, yeah, just want to check an error condition, or you might, yeah, there are several reasons. We want the user to specify what is an error. There is a configuration parameter that you can set and make ReFrame explicitly checking the exit codes of the job scripts, which is not always so reliable. It really depends on the backend that you are using for. Apparently, if you're just running locally, of course it is, or if you're running Slurm with accounting, again, it is reliable, but not in all the cases. And then also the script that gets generated, you must be sure that the last command is the command that you want, the command of which you want the exit code. So for these reasons, it's not the default. Now, I'm going to see the comments later on. So one more offline question. Okay, I will take the questions later on. So apply sanity function iteratively. We've seen already a bit more on sanity functions. Now here we have a Ciligan test that it generates a set of random numbers, and then in that test we want to make sure that all the numbers, they are in the same, they are bounded. So here, what we do is the following. So here we use this extractl thing. We've seen that before as in its form extract single, which we're just extracting a single element of the match. But this one is going to extract all the matches. So here we have a pattern, the file to look at, and here is the capturing group. Here we have named it, and how to convert it. So as soon as this returns, here we have a list of floats. So then it becomes much easier to do our math. So first of all, here we wanted to check several things. First of all, we want to check that the number of the count of the number of numbers we got is actually 100. So then we use this function, the count numbers. This is a bit more generic because it also accepts generators. And then we just make sure that this equals 100. Now, here is the tricky part. So we want to check that each of the numbers we got has its value is bounded between 90 and 100. Now, there is a trick here. So we can't iterate with a for loop. And the reason for that, that's simply a Python restriction. So no, it's not a Python restriction. It's actually a decision we made. So actually, when you have a deferred expression, if you try like those produced by those scientific functions, if you try to iterate over the elements of those lists, it will trigger its evaluation. So you have to do that in an indirect way, in a, let's say, more functional programming style way. So here we say that we use the map. So we use the map and we check that all the elements are bounded, are within those values. And then all of this is deferred. And that's a very nice thing, because here it's a deep expression that is going to be lazily executed at a later stage. And yeah, that's how you can write, you can iterate over elements recursively in sanity patterns. You could write your own function, in which case you could, iterate in a for loop. But if you want to do it in a single liner, that's the way to do it. You can't have like here, we can't have like something like that. This is gonna fail. So in case you want to do it. Another thing here is, let's run, and then I just forgot something. The thing I forgot to tell is the following. So there are three, when you're working with sanity expressions, there are three things that trigger the three evaluation rule. Everything is going to be deferred. So you can assign, you can add, you can subtract, you can do whatever you like. You can combine any expression you want. Everything is going to be deferred for evaluation in the future. There are three conditions that they cannot be deferred. When you try to iterate over the elements of a signed expression, it will trigger its evaluation. When you try to get its truthy value, so either explicitly or implicitly call bool on it. And the third is when you try to print it. Not to print it, when you try to get the str function on it, either explicitly or implicitly. So whenever you write your sanity patterns, these are the three things you need to look at. And yeah, I'm not going to look into the output, but you can check that all the values are apparently between 9 and 100. Now, another thing that keeps coming up usually as a question is how I kind of customize the job script that gets generated. And here we're going to see how several ways. So let's start from the simplest one. I need to keep track of time. Oh, we still have 5 minutes. Sorry. We can continue with this tutorial tomorrow. So here you can use the pre-run CMDs and the post-run CMDs. These are going before the run and after the run command, where the run command is actually the command that that gets srand, for example, or MPI rand. So I'm going to just quickly run it. Here. And then you will see this is what it generates. some things before. And here more or less the pattern that gets generated. So first is the job scheduler preamble, then commands about the test environment. So the things you see, module loads, etc., or exports, the pre-run CMDs, and there's the parallel launcher, the executable and the executable options, and then the post-run CMDs. Now, how about if I want to add additional options? I'm just showing this example, and then we're going to finish it. So sometimes you want to add additional options to the job script, and actually this is pretty easy. So essentially, there is this job descriptor that is generated after the setup phase. So anytime after that, you can, with a pipeline hook here, just I say run before run, and set those options. And this is going to get into the job preamble, not in the ensrun command, the job preamble. And yeah, if we run it, oh, what was the problem? Yes, of course, because the current system is not in the supported ones. So all the previous tests were pretty generic. So then you will see that you will see that we get this thing. And those, they go always at the end. And there is also another trick that you can use temporarily. So you can pass options from the command line yourself. So you can say it's a minus j mem equals, let's put it 500. And you can pass from the command line directly to the backend. And in this case, you're going to see that's an additional thing going here at the end. And this is going to override. Yeah, you rely on the scheduler's logic here. It's going to override what's in the test. So I'm finishing here, and we're going to continue tomorrow. I'm going to take any questions offline in the chat.
Yeah, I think we best end the stream and the recording here. There's time for questions in the Zoom session as well, but we need to avoid overlapping the stream. So let me end the stream here.
Okay, yeah. So I can stay here for
yes
any questions.